All right, now the flowcharts, remaining part of it. We will be covering reading, means tracing of the flowcharts, creation of the flowcharts, and fill in the blanks flowcharts. Okay. So first, let's discuss about the flowcharts. Flowcharts are the graphical forms of pseudocodes. There are so many symbols of the flowchart, but we only use 4 or 5 of those symbols to create the flowcharts. There are 2 areas of flowcharts that we have to cover. One is tracing. Tracing part strictly belongs to pseudocode. जिस तरीके से हम pseudocode लिखते हैं, loops चलते हैं, sequence होता है, selection होती है, if then else होता है, tracing works that way. But for the fill in the blanks part, this is no pseudocode. This is another system called monitoring and control. Monitoring and control is talking about the mechanism which is happening with the help of machines. Like there's a door, when someone walks in, door gets opened. There's a greenhouse that is controlling oxygen and temperature. So anywhere where there are sensors and machines are basically controlling the environment, or maybe sometimes the procedure of stock control, stock. So fill in the blanks related flowcharts are basically from the real world scenarios where something is happening. Tracing flowcharts belong to the pseudocode side, where we have to evaluate every single statement and see what is the fact of that statement over the variable, and then we have to note it down. And then creation is all different case, when we would have a pseudocode given in a written form, and then we will have to actually create a flowchart. So as I said, that whether it's a computer language, it's a pseudocode or flowchart, they all are algorithms and they can be interchangeably used. So whatever the pseudocode that you have written, you can create a flowchart for. So let's first solve questions related to flowcharts, and we will be solving from latest to oldest. So latest questions from November 19, let's start doing them, and we go up towards the older questions, and we will try to solve as many as possible. And in this go, we will be tracing and we will be filling the blanks both, and we will be discussing flowcharts. All right, so let's do that. So this is November 19. I'll send this document out to you today in the group as usual. November 19 P23. Describe the use of a subroutine in the program. We discuss about it, that subroutines are, this is an irrelevant question, so move on to the next. Draw 4 different flowchart symbols and describe how they are used in the program. So I'll write a bit more. You only restrict yourself to drawing of the symbol. Whenever there is an assignment, means A is equal to 5, B is equal to C, maybe X is equal to A squared plus 2AB plus B squared. So whenever there is assignment means the right side is being assigned to the left, the right side is being assigned to the left, the right side is being assigned to the left. This is called process This is called process. A process is happening, and the symbol is any square or rectangle with 4 corners. Okay, this is called process. So whenever you see this symbol or this symbol, but this symbol you have to be very careful. If A is equal to 5, then in that case it is not a process, it is selection. But if it is just A is equal to 5 without if, then it is basically the process. Then comes selection. Decision or condition. Okay, this is actually the diamond shape. I'm not a good drawing person, but this is what the shape is. So you enter and then you get out. You enter, if it is true, you get out from this side, and if it is false, you get out from this side. But in flowcharts, we do not write, usually, it is not a must, but we do not write true and false, rather we write yes and no. Or maybe it is yes on the right and no on the left, or maybe no on the bottom, yes. But it is, once you enter this particular shape, which is a diamond shape used for selection, decision, or condition, you might get out from 2 possible paths, one when it is condition true, one when it is condition false. And then input and output, this is parallelogram. Remember, 2 diagonal lines, and then this is input and output. Since it is the same symbol for input and output, so when we are using it for input, we have to write input, and when we are using it for output, we have to write output in it. So when it is simply written, no one would have idea whether the value is being output to the screen or printed to the screen, or whether the value is being input from the keyboard. So you have to write input and output. Then the other symbol that we have is start and stop. Again, it is the same symbol for both. Okay, so this is start, stop, begin. Sometimes people write begin and whatever. And then we might have arrows. Arrows might go top, towards bottom, towards right, towards left, but do not use diagonal arrows. That's not a restriction, but it's a good idea. We call them flow lines, that tells where to go. So just these 4 symbols and flow lines are used. Flow line itself is a symbol, but whenever they ask, please be attentive. Okay. Now, 4 validation checks and 4 descriptions are given. So this is a good idea. Learn from this description, and whenever they are, just explain it. Checks that some data is entered, that is presence check. Checks for the maximum number of characters in the data that are entered, that is length check. Checks the characters entered are all numbers, maybe type check. Check the value entered is between an upper and lower value, that is range check. So if it is just upper or just lower, then it is limit. If this is both sides, then it is range. Now, this is a flow chart which is based on the process of pseudocode. Okay. So this is reject, count, length, and output. Values those are being entered are 24.88, 25.01. So let's start with 24.88. Reject is equal to 0. This is a process. Values are being assigned. So reject is equal to 0, count is equal to 0. Then we go with the arrow. We do not care if another arrow is coming, we just go with the flow line. Is count is equal to 10? No, count is 0. So we go with the no part. Input length. Length would be what? 24.88. So length is 24.88. Is length is less than 25.1 and length is greater than 24. No, it is not less than 25 and greater than. How come any length would be less than 25.1 and length is greater than 24 point? Okay, so this is between 24.9 and 25.1. So means 24.9 to 25 and then 25.1. Okay, no, it is 24.88. So no, reject is equal to reject plus 1. So reject becomes 1 and then you go with the arrow and count increases by 1. Okay, is count is equal to 10? No. Input length. So next. Next one is 25.01. 25.01. So is length is less than 25.1? Yes. Length is greater than 24.9? Yes. Then we go to count is equal to count plus 1. 2. And that is how it will increase. And ultimately you would have to output that how many batches are actually rejected. Or the batch, if the batch is rejected or not. Okay. If reject is less than or equal to 1, then yes, batch accepted. And if batch is not less than or equal to 1, then batch will be rejected. So you have to actually go on with it, and ultimately you would see that if the reject count is greater than 1, then you will have to output this, otherwise you will output this. So this is easy one. Explain what is meant by the validation and verification. Now this is a good thing. Try to understand what is validation and verification. When a computer is sending data to another computer, we use parity and checksum. When a computer to computer transfer of data happens, all right, then it is verification. Okay, so if someone enters manually data to a computer, then it is validation. Check digit is validation. Checksum is verification. Parity is verification. Whereas length check limit check, type check, presence check. They all are what? Validations. All right, when data is being transferred from computer to computer, either Bluetooth, Wi-Fi, whatever, that is checksum and parity. Those are verifications. And if it is data being entered, then check digit length, limit, type, presence, these are validations. So when humans are entering data, that is validation. When computers are entering data, then it comes to verification. So these are the examples. Checksum and parity are verifications, and check digit length, limit, type, presence, etc. These are validations. Okay, total is equal to 0, count is equal to 0, distinction is equal to 0. Total is equal to 0, count is equal to 0, and distinction is equal to 0. Then it says that input mark, so we input mark 50. If mark is equal to -1, no. Is mark is greater than 80, no. Then total is equal to total plus mark. Then total is equal to total plus mark 50. And count is equal to count plus 1. So 1. Go back, input mark is 70 now. So whenever there is a new input, go to the next line. In any other case, do not worry about it. Whenever there's a new input, go to the next line and start inputting all the values from that line onward. And as soon as the new input comes, leave that line and go to the new line. That is a simple case. Do not worry about how it is written in marking scheme, how your teacher has taught, how someone has said. So this is a simple rule. Whenever there's a new input, go to the next line. Otherwise, you are free to write in the same line. So input 70. 70 is equal to -1, no. 70 is greater than 80, no. So total is equal to total plus mark, and count is equal to count plus 1. 120 and count is 2. Input mark is 65 now. So is mark is equal to -1, no. Is greater than 18, no. Total is equal to total plus mark. So that is 185 and count is equal to count plus 1. Input mark is now 30. Is mark is equal to -1, no. Is mark is greater than 18, no. Total is equal to total plus mark. So mark is what? 30. $215, count is 4. Input mark again, 95. Is mark is equal to -1? No. Is mark is greater than? Yes. Then distinction is equal to distinction plus 1. Now distinction will be 1. Once a new input is there, we started from the next line and we will never write before that line. That's a case. And then total is equal to total plus mark. And count is equal to count plus 1. Then input mark, that is 50. And that is how you go. And once it is -1, then it will get out. So remember that all the values which are given are not required to be input, since here you can see that is mark is equal to -1. If it is -1, you get out. You are no more inputting 45. So do not get confused. All right. That is how it works. We have already done this. Draw flowchart representing this section of program code. So let's see. This section of program code may be used as a validation check. Print input a value between 0 and 100 inclusive. Input value while value is less than 0 or greater than 100. Print invalid value. Try again. Input value and while print accepted value. Give the name of this type of validation. So this is range check. Describe what is happening in this validation check. A value is being entered and checked for if it is between 0 and 100 inclusive. If not, then repeatedly ask inside a loop. That is simple most thing. A value is being entered and checked for it for if it is between 0 and 100 inclusive. Why inclusive? Because if it is checking 0 for less than 0 or greater than 100, it means that 0 and 100 are inclusive. And then repeatedly check inside a loop. So Arham Khan, this sir process block contains only assignments. Yes, only assignments. And sir flowcharts में ज़्यादातर range check लगता है. भाई मुझे क्या पता, ऐसा कुछ नहीं है, कोई सा भी check लग सकता है. Complete the trace table for this program using value 200, 300, -1. You do it yourself, and the next part is more important to us now. That is, draw a flowchart to represent this section of the program code. Now this has started coming up in exams. So always start with the start. Then it says line number 1. You should not use this 1, 2, 3. I'm just using it for the sake of saving time. But you would have to write inside it output, input a value between in double quotation. And then input again, input value to, this is input and output symbol, while. So we have to check. Now there is no symbol for while, so we will be checking. If value is less than 0 or value is greater than 100, we have to put a question mark there. If that is yes, then we will be printing 4 here, and then 5 here, and we go back to check, because we have already inputted. Okay. If it is no, then we use 7. So you see, there is no such thing for while and end while. We have to control it using, I am using symbols on left and right. You would have bigger space, so make it neatly. That is why I don't like it actually, because they are untidy and they take a lot of space, and sometimes you need to raise it again and again. So I basically think that this is, until unless asked, we don't have to actually create these flowcharts. All right. But they have started asking for it, so you might have a flowchart and you might be asked to create a pseudocode out of it or vice versa, but that is the game nowadays. So let's see what this says. Input height, depth, and chlorine. I think this is uh, belonging to a swimming pool or something. Let's read the question. The flowchart checks the level of chlorine and the depth of water compared to the height of swimming pool. Error messages are output if the problem is found. So start input height, depth, chlorine. So let's do that. Height is 6, depth is 2.5, and chlorine is 2. So 1, 2, and 3. We have actually input all. Now, is depth is greater than height divided by 2. Height divided by 2 will become 1.25. Sorry, height divided by 2 will become 3. So depth is not greater than. Depth is what? 2.5 and height is 6. If depth is less than 3, yes, it is. Sorry. Depth is 2.5 and height is 6. So, yes. If depth is greater than 3, no. That is no. Is depth is less than height divided by 3? That is 2. Height divided by 3 is 2. Depth is 2.5. So 2.5 is less than, no. Is chlorine is greater than 3? Chlorine is 2. No. 2 is greater than 3? No. Is chlorine is less than 1? 2 is less than 1? No. Is OK is equal to true? OK is equal to true. We have not input OK or anything. OK is equal to true is here. So it is true. Yes. Output pool OK to use. So pool OK to use. All right, do the rest yourself. Let's see what they ask further. Identify a problem with the algorithm that the flowchart represents. Identify a problem with the algorithm that the flowchart represents. So start input, okay, height, depth. This depth is less than 3. This depth is less than height divided by 3. Okay is equal to false. I think the problem is that if OK has become false, then still it is going on with the further checks. So it should not. If it is OK not false, then it should go to the end of the flowchart instead of checking it further for any other values. Okay, so this basically should go to the end, something like that. Okay, so let's check further. Hold on for a moment. So let's move on. Write an algorithm using pseudocode. This we have completed. Give two sets of data, test data. Now let's talk about test data. You see, we have done a validation as well. So you can say that if like it is with reference to the previous one, what are the errors in it? So one error I told you that if it is not okay, it goes further. The other error can be there is no validation check. Third error can be it only works once. You might put it into the loop until it is satisfied, then it gets out. The algorithm only work once. There are no validation checks. It only works once, and if there is an error, the pool does not require to be checked again. And you might say that if it says that something like add water and all, so we have to have it inside the loop. Okay, so if it is not inside the loop, we cannot constantly check it for its conditions. So it is only checking once and then. So let's check this question, which is basically uh, give two sets of test data. Now, what is actually test data? Test data is mostly it is applied to range. Okay, so test data is basically applied to range. So let's say we have to enter numbers from 10 to 20. Okay, these two numbers are having numbers in between 11, 12, 13, 14, 15, 16, 17, 18, and 19. So this 20 and 10 are extreme values. These are extreme values. Values inside these two extreme values are okay values. We do not need to reject them. We can accept them. And values outside the range means greater than 20, 21, 22, 23, and so on, or maybe 9, 8, 7, and less than that, they will be rejected. Okay, so this is called normal data. At the boundary, that may be sometimes called boundary data or maybe extreme data. And if it is less than that, that is basically abnormal. Now, range is basically numbers. So if someone enters instead of 1, they enter 1. So this is not number, this is text. So it will be rejected. Now this particular algorithm has three inputs, number 1, number 2, and number 3. Alright, so test data will be built around 3 numbers. So what does this algorithm say? It says that write an algorithm using pseudocode to input 3 different numbers and multiply the 2 large numbers together and output the result. What if these 3 numbers are equal? So 6, 6, and 6. So how would you check which one is greater than which one is not? So these values will be rejected because they are equal. Let's make second one. So let's say 3 numbers, 3, 2, and 9. So this is normal data. And result would be what? 18, not 27. So this is basically the minimum one, rest 2 will be multiplied and the answer would be 27. So that's about it. I'll go further. So it says that program checks that the weight of a basket of fruit is over 1.00 kg and under 1.10 kilograms. Weights are recorded to an accuracy of 2 decimal places, and any weight not in this form has already been rejected. Give 3 weights as test data, and for each weight state a reason for choosing it. So this one is basically May June 2018 P22. So this is question 5. So how many types do we have? Boundary, normal, and abnormal. So 1.00 to 1.10. 0.01, 02, 03, 04, 05, 06, they all are acceptable. And over greater than 1.00 and under means less than this. So 1.00 itself and 1.10 are abnormal. Anything between is normal. Okay, and 1.01 will be extreme value here, and over here it would be 1.0000001, 1.09 will be extreme values. These are extreme. So give 3 weights as test data. So let's say weight 1 is 1.01. That is boundary or extreme. Accepted. Weight 2, let's call it 1.02. This is normal and accepted. Let's call it 1.10. That is abnormal and rejected. Okay. Now draw a flowchart for an algorithm to input numbers Reject any number that are negative and count how many numbers are positive. When the number is 0, they have specifically asked for the flowchart. You see, specifically they have asked for the flowchart here. Reject any numbers that are negative and and count how many numbers are positive. When the number is 0, the number 0 is input, the process ends, and the count of the positive numbers is output. Explain the changes you will make to your algorithm to also count the negative. Okay, so draw a flowchart. So whenever we start drawing the flowchart, we will first start, and then we will leave some space for the process of initialization. I'm not writing anything, neither I'm closing it, for the reason that we would have to initialize. What are the variables? We don't know. To input numbers. So we will input a number. Reject any number that are negative and count how many numbers are positive. So if number is greater than 0, yes, positive number is equal to positive number plus 1. No. So we have rejected it. So if it is greater than 0, we have counted it in positive number, and if it is not greater than 0, it means it is negative. We have just rejected it. And count how many numbers are positive. So we would have a counter there as well. When the number 0 is input, the process ends and the count of the positive number is output. Now another check. Is number is equal to 0? If it is no, it goes back and takes next input. And if it is yes, is output positive number, and then it ends. Now what are the variables? Num is equal to 0, positive number is equal to 0, and that's about it. Now it says in part 2, explain the changes you will make to your algorithm to also count for negative numbers. So let me first tell you, if it is no, then we would have a counter over here as well for, let's say, negative number is equal to negative number plus 1. Instead of rejecting it, we will have another counter for negative numbers, and that counter we will then output towards the end. Okay, or we may have another check if it is less than 0. So in that case, we will take this whole thing and make it again once over here. If number is less than 0, then negative number is equal to negative number plus 1. So all you have to do is to explain. You don't have to actually make it. Yes, you can use around any variable. Variable name is your own child. Name it whatever you like to. Okay, let's see. A programmer has written a routine to store the name, email address, and password of a contributor to a website discussion group. The programmer has chosen to verify the name, email address, and password. So this is a different question. I forgot to put the name of the person here. So the programmer has chosen to verify the name. Remember, this is verification. Email address and password. Explain why verification was chosen and describe how the programmer would verify this data. Verification because the details do not have fixed values or lengths. Means name is not fixed, email addresses and passwords are not defined. So that is why we have to just verify whether the data has reached to the website or not, and that's about it. Secondly, validation requires rules. There are no rules defined here. So we won't be actually using validation, rather verification. The programmer has also decided to validate the email address and password. Describe the validation checks that may occur. Email, we know that in email address, we check for @ symbol, or we may have a format check. We can ask for, we don't require any spaces in between. Only valid characters can be used. There might be a presence check. There might be a length check. Maybe length check for email cannot be for more than 255 characters. And there might be a uniqueness check. Uniqueness check is a validation that basically checks whether the values which are now being entered, if they are already entered. So sometimes when you enter the email address or a username, the website says that that is already used. So you choose a new one. All right. So for email, we might have presence check, format check, check for @ symbol inside it, uniqueness check, length check, maybe anything that you would like to put into it. Now May June 18, it says in 4, a programmer has written routine to check the prices below 10. These values are used as test data. Below 10. So this is abnormal. This is basically below 10. And this is normal. This is extreme, or this is abnormal. I think this is extreme values. 10, up to 10. 10 is, some people might take it for extreme or boundary values. Some people might take it for error and abnormal values. That is fine. Since you will be explaining, there would be no harm. So if you feel like there is a confusion whether this 10 is included or not. If people think that if it is included, they will make it boundary or extreme data, it will be accepted since they have explained it as well. 9.99 is normal for 100% reason. If you make 10 error abnormal, then 9.99 will become boundary. So it's up to you. But for sure, TE and 10 is abnormal. This is errorful data and it will not be accepted. So in part A, write an algorithm to input 1000 numbers, count how many are, use either pseudocode or flowchart. So I leave it to you, do it yourself. Give one change you can make to your algorithm to ensure initial testing is more manageable. So one change would be validation for sure. One change will be validation for sure. Candidates, you should use the validation. So if the number is being entered and if there is no validation, then the thing might go wrong. All right, so for validation, so that it could be checked against uh, the, uh, the data, abnormal data, and normal data, and extreme data. Yes, this is a flow chart which is basically sorting. It is sorting the data in ascending order. See what is happening. The flowchart below represents a program routine. Before we go any further, I would like to explain something. When we sort numbers, this becomes easy for us to compare them. For example, 3 is greater than 2. We know, yes, that is true. But if it is like my name, Zafar, is greater than Ahmad, how we will compare this? I need to basically explain this. So when computer compares non-numbers, or let's just talk about text or string, when computer compares a string, it does not compare the whole thing. It rather takes only the first letter. You might know that every character is having an ASCII number, ASCII code. All capital ABCD starts from 65, 66 and goes until 90. And small ABCD starts from 97, then 98 and goes up till 122. So if it is capital Z and capital A, definitely it is true. But if it is small z greater than, or sorry, if it is capital Z greater than small Ahmad, in that case computer checks first two letters. So this capital Z is having what, 90 code, and this small a has what, 97 code. So this is false. You have to take care of it. All right. So let's say if someone has written if Ahmad is less than Ahmad, computer starts comparing first two letters, they are same, it goes further. It checks second two letters, they are same, it goes further. It checks third letters in both, it goes further. And then it checks fourth letter, here E and here it is A. So it is false. Because E is having 101 and A is having 97. So this is basically, this Ahmad with small e is greater than Ahmad with A. I hope that you got the idea. This is actually absolutely necessary to understand. When we are comparing text instead of numbers, we know that computer takes everything in the number form the thing is in number form, it is in binary form. If it is in binary form, computer can make sense of it easily. So mind it, that thing will actually help you to understand this particular algorithm. Let's see how. So start, flag is equal to 0, count is equal to 1. Is name count means name 1. So let's see what is name 1. Name 1 is Jamal. Is name 1 is greater than name count plus 1 2. So if Jamal is greater than Amir, that is true. J comes later, A comes before. A is having code 65, J would have code greater than 65. So Jamal with big J, Amir with big A are when compared, Jamal is greater than Amir. Yes, then temporary is equal to name count. So let's do it over here. So flag is 0, count is 1. Temporary is basically name count. So that is temporary is now Jamal. And then it says name 1 is equal to name plus 1. So name 1 has now become Amir. Name plus 1 is 2. So name 1 has become Amir. Name 2 is equal to temp. So name 2 is equal to Jamal now. And flag is equal to 1. So now flag is equal to 1. Where is flag? Yes. Then count is equal to count plus 1. Okay, count is 2. Is count is equal to 4? No. We go back. Now, count is now 2. So if name 2 is greater than name 3, let's check out what is name 2 and what is name 3. Name 2 is Jamal now, no more Amir. If name 2 is greater than name 3, yes, Jamal is greater than Eve. J comes after Eve. So Jamal is greater than Eve. Yes, that's true. Now it says that temporary is equal to name 2. So temporary is again equal to name 2. If it is same, even then you have to write it again. Name 2 is equal to name 3. Count plus 1, 3. So name 2 will become Eve. No more Jamal. Name 3 becomes equal to temp. So name 3 has become now Jamal. No more Eve. Flag is equal to 1. So flag is equal to 1 once again. Then count is equal to count plus 1. Count is now 3. And it goes back. Is count is equal to 4? No. We go back. Now count is 3. So is name 3 is greater than name 4? Now let's check. Name 3 is Jamal and name 4 is Tara. JKLMNOPQRST. T comes way ahead of Jamal. So Tara is greater than Jamal. So it is now no more true. Name 3 is not greater than name 4. So we go down and we just count. Count is equal to 4 now. Is count is equal to 4? Yes. Then we go forward. It is now 4. We go forward and it checks. Is flag is equal to 0? No. Flag is equal to 1. We go back to the upper loop. Now we will make it again. Flag is equal to 0. Count is equal to 1. So flag is equal to 0. Count is equal to 1. Now remember, name 1 is Amir. Name 2 is Eve. Name 3 is Jamal. Name 4 is Tara. Amir, Eve, Jamal has swapped their spaces, their locations. So let's start again. Is name 1 is greater than name 2? Amir is greater than name 2. Eve, no. We go down and we count. Count is now equal to 2. So let's copy it down so that we don't have any further confusion. If name 1 is greater than name 2, no. We just counted. Is count is equal to 4? No, we go back. Count is now 2. Is name 2 is greater than name 3? Let's check. Is Eve is greater than Jamal? No. We again counted 3. Is count is equal to 4? No, we go back. Is name 3 is greater than name 4? Let's check. If Jamal is greater than Tara? No. We just come down and we increase the count by 1, that is 4. And now we check. Is count is equal to 4? Yes. Is flag is equal to 0? Yes. Then we get out. That's it. So if you could see, these values are actually now in ascending order. This particular type of ordering methodology algorithm is called bubble sort. This is just for your knowledge. This is not part of your syllabus. So again, like binary search, they have used this bubble sort, but without naming it. All right, so the new thing that you have just learned is how to compare strings as they are numbers. All right, this is bubble sort. You don't have to actually put your mind into bubble sort. All you have to do is to go with the flow in a flow chart to trace it. All right, so let's see. Describe what the algorithm represented by the flow chart is doing. So you don't have to mention bubble sort. All you have to do is, it is sorting values inside the name array in ascending order. That is how you will have to answer. If you don't get what is happening, just have a look at input and then the output. Compare them and you would have at least a little idea that what's going on. Explain the difference between validation and verification. I hope that you got the idea of this string comparison. This is actually very necessary. Okay. And a few of the students, they ask whether we have to actually fill the spaces in between. It's totally up to you. If you like to fill spaces, you can repeatedly fill, like 1 over here, 0 over here, Amir, Amir, and then Amir, 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 Amir. But to me, it looks useless. All right, so you don't have to. Whenever there's a change, you go with that. Whenever there is no change, just don't write it. Okay, do not care about marking scheme. They consider any sort of a strategy as far as your output is correct. Now, explain the difference between a validation and verification. So validation checks, but a class will end when this part, making of flowchart, tracing of flowchart, and fill in the blanks of the flowchart is finished. I think another half an hour. Validation checks whether the data to be entered is possible or if it is sensible and it is correct according to the rules given. It's sort of computer check against few code lines. Verification checks that data entered is the data that was intended to be entered. Means if the data that is transferred is correct, if the data that was sent is actually received the way it was sent, with parity check and checksum and all. B. Describe using an example how data could be verified on data entry. Verification. See, verification. There are two ways verification can be seen. Verification. Verification is in communications. Verification in manual data entry and its transfer. What does it mean? When we enter data over the keyboard, has it transferred properly to the computer or not? Something like that. So for communications, it is parity and checksum. And for manual, it is double entry and it could be double entry and what do we call it? Visual check. So we know what parity checksum is. It is used in double entry is asking someone to enter data again and again. Now, what comes to your mind at first? Whenever you enter your email, system asks you to re-enter your email. That is not double entry. That is validation because it is applied to just one data item. If you enter your password for the very first time, they ask you to re-enter the password. That is not verification. That is validation. Verification is when the whole data, the whole form is being entered again. So when we enter the data, we ask two persons to enter the same data in two different computers, or the same person to enter the data twice in the computer, but as a whole, not just one field. If it is one field being re-entered, that is validation. So when two persons over two different computers are entering the data, the computer matches them. If the two match, it means verified. If the same person enters the whole data and computer matches it, if the two entries of the full data is matched, then it is verified. Visual check is like, जब आप नादरा पे गए होंगे, आपने अपना शनाख्ती कार्ड बनवाया होगा, तो उसने आपको सारी आपसे आपकी डिटेल पूछने के बाद प्रिंट करके आपको फॉर्म दे दिया होगा। अब आप फॉर्म को देख रहे हैं और उसको आपने कहा सही है, उसने कहा साइन कर दें, तो साइन कर दिए, वेरीफाइड। और दूसरा ये है कि आपने जिस फॉर्म से डाटा एंटर किया उसको आप स्क्रीन के बराबर में रख के विजुअली मैच कर लें, दैट इज वेरिफिकेशन। ओके, सो गेट द आइडिया। डिस्क्राइब यूजिंग एग्जांपल हाउ डाटा कुड बी वेरीफाइड ऑन डाटा एंट्री। सो डाटा एंट्री की वेरिफिकेशन जो है वो या तो डबल चेक होती है या विजुअल चेक होती है। Explain what is meant by the term library routine. We have already discussed about it. This you will do easily. Write an algorithm using pseudocode flowchart to input a positive numbers. We have already done it. This must be easy as well. Write an algorithm to input three different numbers and then output the largest number using either pseudocode flowchart. This is very easy. For count is equal to 1 to 3, input number. If number is greater than highest, then highest is equal to number next, and you get out of these three numbers loop and output highest. And you don't forget that highest will be initialized on -1000. There is no different thing in it, so let's leave it out. Practice it yourself. Yes, this is different. So this is June 2017. This is June 2017. The section of the program, sorry, this is question 3. A satellite navigation system works using destination. Remember that term that we use, structure chart, top-down design. It is sort of that question. Let's see what it says. A satellite navigation system works using destination details entered by the user, either a new destination or chosen from previously saved destinations. The satellite navigation system will then output directions to the destination in the form of either a visual map or list of directions. Google Maps. A satellite navigation system is an example of computer system that is made up of subsystems. Remember, subsystems. This structure diagram shows some of its subsystem. Complete the diagram by filling in the empty boxes. Now they have left it to you. They have explained it and they have left it to you. It's up to you now. How would you actually? So input destination. So that would be, as they said, output directions. Now, there is no hard and fast rule learning this. This is all out of your own instinct. Whatever that you understand, just put it. An input destination is either a new destination or chosen from previously saved destination. So you may like new destination or maybe saved destination. See, it is coming out of their words. You would have to choose it yourself that how would you put it. Anyways, no matter how much you study, a little part of the question paper will be something that you might have not expected. So this is basically the test of your skills, computer skills and general understanding sometimes. Now, for each of the 4 statements in the table, place a tick in the correct column to show whether it is an example of validation or verification. So the first one is to automatically check the accuracy of a barcode, that is validation. To check if the data input is sensible, that is validation. To check if the data input matches the data that has been supplied, that is verifications. Because that is not against the rule, it is just for checking. Just checking for the data that is arrived or not. To automatically check that all required data fields have been completed, that is validation. You need to practice this tracing of the flowchart. That is absolutely necessary. You cannot get away with it. So at least try 10 to 15 flowcharts tracing yourself. At least 10. Pay attention to this div and mod thing. All right, so that's about it. Now, let's see. We have covered creating the flow chart. We have covered tracing, but fill in the blanks are no more appearing. We have seen all of the questions since the beginning of 2015, which is the start of your 2210 syllabus. There are no fill in the blanks flow charts, and they are no more appearing, so leave it out. Is logo part? That is one very interesting question. Logo is based on Microsoft logo language. It is used to be the part in the older syllabus, that is 7710. This is no more part of it, so never appeared. You see, since the beginning of your syllabus, that is 2015 June, I have covered all of the questions. All of the questions. Okay. So anyways, tomorrow is the last class, and we will be covering pre-release material. I'll start at 5:30. If it gets finished in 2 hours, I'll finish my class in 2 hours. If it gets finished in 3 hours, I will finish my class in 3 hours. So tomorrow would be the last day of the crash course, and we will be finishing pre-release material. All right. So let me check. We have covered database, miscellaneous. While we were solving question, whatever miscellaneous thing appeared, we covered that. We covered pseudocode, gladly. We covered flowcharts, gladly. So algorithms are completed. So see, everything that was in P2 is now covered. A big star. Okay. So everything is covered. P2 leaving PRN is covered. In any area which might be required to be covered, it is covered. ठीक है जी. If there are any questions to ask under the video or in your WhatsApp, I will definitely be glad to answer those questions. And tomorrow would be the last day of this crash course, and I will be covering pre-release material, and we will start at 5:30, and we might go in length for 3 hours maybe, or if it gets finished early, we will finish early. See you.